All right, the last homework is homework 24. It just has two topics, both are having to do with sign tests. It says a coin-operated coffee machine was designed to discharge 8 ounces of coffee per cup. In a test of the machine, 17 cupfuls of coffee were drawn from the machine and measured. The number of ounces discharged for each cup of coffee is 7.5 ounces, 7.75, 7.89, 8.24, and so forth. At the 0.05 level of significance, can we conclude by using a sign test that a mean discharge of a cup of coffee from this machine differs from 8 ounces? Perform this hypothesis test by completing the table below. If necessary, consult a table with critical values for the sign test. It is going to be necessary to consult that table, so first thing you're going to want to do is print it out. I'm going to hop over to Alex. On Alex, when I have my question there, you'll notice here when it said if necessary, consult the table, that you can click on that. And so I'm going to go ahead and open that up. It's going to bring up a table with the critical values. My table with my critical values, I have my numbers in there, and here my numbers from 8 to 25. It's either going to be a one-tailed test or a two-tailed test, and then the appropriate critical values that I want to check my level of significance will be in there. And so you'll want to print that table out. I've got it printed to use for reference here, but you're going to want that table so that when you work the problems, you can look at the table and find those values. So I'm going to leave that up there for a minute, just when I hop back and forth, it erases what I have. So on here, we want to check to see if it differs from 8 ounces. So our HO, our null, is going to be, is it equal to 8 ounces? Our alternative one, it is not equal to 8 ounces. What we're going to do is assign a sign to each of those numbers. Is it above 8 ounces, it'll be positive. If it's below 8 ounces, it'll be negative. If it's exactly 8 ounces, it's going to be 0. So 7.65 will be below, it's going to be negative. 7.75 will be negative. 7.89 will be negative. 8.24 is above, it's going to be positive. 7.92 back to a negative. 7.73 is a negative. 7.72 is a negative. 7.73 is a negative. 7.75 is a negative. 7.93 is negative. 7.73 is negative. 7.80 is negative. 8.22 is a positive. 7.75 is a negative. 8.00 is exactly 8, so I'm going to give it a 0 number. 7.91 is a negative. 7.70 is a negative. So anything that's below 8 is going to have a negative. Anything above 8 is going to have a positive. If it's exactly 8, we're going to give it a 0. So what we're going to do here is we want to know how many values in our table do we have a plus or a minus. In other words, we're going to ignore this one that was exactly equal to 8. So now we have n equals 16 because we originally started with 17 numbers on our list, but we had to take one off of our list. So on our table, we are going to look at n being 16 and that it is a 0.05 level of significance, and because this is a not equal, we're going to use, or an equal and a not equal, the two-tailed test. So that's probably going to erase all of my writing, but I'm going to flip over to that table just so you can see where we get that number from. And so here's my number. If I look at 16, two-tailed test. So here's my 16. I'm doing a two-tailed test with a 0.05 level of significance. So my critical value is going to be 3. Okay? If I go back to my pluses and minuses, which I might have to rewrite again. We'll see here. Yep. Again, if I just quickly do this, negative, 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 positive, negative, 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 positive, negative, 0, negative, and negative. If I count up my negatives and positives, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 negatives, and 1, 2 positives. The value of the test statistic is going to be whatever number is lower. In this case, the positive number was lower. It's going to be 2. My critical value is going to be that number we just looked at in the table. When we had n equals 16 at a 0.05 two-tailed test, we got 3 for our critical value. So, if the test is less than or equal to the critical value, we are going to reject the null. If the test is greater than our critical value, we are going to accept the null. Remember, we have to do the equal there when we are going to do the less than or equal to. So in this case, comparing my two numbers, 2 is less than or equal to 3, so we are going to reject the null. The null again was that it was exactly equal to 8 ounces. The alternative one then is that it's not equal to 8 ounces. So this is my true statement. That's the one that's not true because we rejected the null. So can we conclude that the medium discharge of a cup of coffee from this machine differs from 8 ounces? It's not equal to 8 ounces. That's the true statement. So yes, we can conclude that. Whoops, I skipped the decision. My decision here is in the drop down that we're going to reject the null. It'll either say accept the null or reject the null. In this case, we're going to reject the null. And so does it differ? Yes, it does differ. So basically just going to put your signs in there, count them up. How many negatives, how many positives, whichever number is lower is your test statistic. We're going to look up the critical value on the table. We're going to make the decision. If it's less than or equal to, we reject it. If it's greater than, we accept it. And then we can answer our question. So if we look at number 2 here. Number 2 says, a random sample of 21 male students at a local university was selected. Each student reported his height in inches and his height was measured. The results are as followed. So here's the reported height, here's the measured height, here's the difference in what they really reported. So we're checking to see, well, how close are they to what they thought they were? At a 0.5 level of significance, can we conclude by using a sign test that there is a difference between the reported height and the measured height of the male student? So, on this one, is there a difference? We would say that the null is does it equal 0. If it's 0, they were exactly right. If there is a difference, it's not going to be equal to 0. So are we checking, were they exactly right or were they off by a little bit? Again, we are going to use our sign test and we're just going to look here at our numbers. Since we're comparing it to 0, if it's negative, it's going to be negative. If it's positive, it's going to be positive. And if it's 0, we're going to cancel it out from our list. So in this case, we got a negative, a positive, a positive, a positive, a positive, a positive, a positive, a negative, a positive, a positive, a positive, a positive, a negative, a negative, a negative, a positive, a negative, a positive, a negative, and a negative. We don't have any zeros in this case. So we are going to use all 21 for our n because we didn't have any that were exactly equal to our null. So n is going to be 21. Again, we're going to use a 0.05 level of significance. We're doing a two-tailed test. Again, I'm going to erase this so I can go back and look at my table, but we'll put those back in there. So again, when I look at my table, oops, I got to go over here. On my table, if n is 21, if I could draw straight, and I do a 0.5 level of significance on my two-tailed test, my critical value is going to be 5. I go ahead and look that up right away. My critical value is going to be 5. So back here, my critical value, hey, I put my stuff back. All right. Now it's not going to let me write. Oop, maybe it's going to let me write. I'm getting there. All right. My critical value is going to be 5. We figured that out. If my thing does not want to work right, you give it a second. See if I just use my pen tool. Nope, still doing the same thing. 5 doesn't want to work. Let me clear it and see if that works then. There we go. My critical value is 5. Again, for the value of my test statistic, I'm going to count how many negatives and how many positives. I erased all those, but we can still tell from the numbers. You probably have them written down, I hope. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 negatives. Positive numbers, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That should add up to 21. It does, because n was equal to 21. So in this case, my test value is the lower of those two numbers. 9 is the lower of those two numbers. So 9 is my test value, 5 is my critical value. So I am going to go ahead and compare those two numbers. 9 is greater than 5. Since my test value is greater than my critical value, I am going to accept the null. So that's my decision, accept the null. Now again, on this case, it erased what I had written down, but our null said we were exactly equal to 0. There was no difference. Our alternative one, it's not equal to 0. There is a difference. So in this case, we're accepting the null. This is my true statement. That one is not true. So can we conclude that there's a difference between the reported heights? No. We're saying that it is exactly equal to 0. There's not a difference between their heights, or at least not enough to say at a 5% level of significance that there's a difference. So if we're going to accept the null, we're not going to have a difference. If we reject the null, then we say, yes, there is a difference. All right, one more of these. A toy manufacturer claims that the median amount of time that their top-selling toy captures children's attention is greater than 30 minutes. To test this, the sample of 11 children is selected and their attention span in minutes while playing with this toy is given below. So 20.8, 33.4, and so forth. At the 0.025 level of significance, can we conclude that the median attention span for playing with this toy is greater than 30 minutes? So on this one, it's a little bit different because now we're doing a greater than. Again, when we do our null and our alternative one, the alternative one is going to be greater than 30. The null less than or equal to 30 because the equal has to go in with the null, right? Way back we started all this stuff. We said the equal always has to be with the null one. So in this case, we're just going to do a one-tailed test. So we're going to look and compare for 30. We've got below 30, above 30, above 30, above 30, above 30, exactly 30. We're going to take that off the list. Above 30, exactly 30, we take that off the list. Above 30, above 30, above 30. So now, how many do we have on our list? 1, 2, 3, 4, 5, 6, 7, 8, 9. n is going to equal 9, 0.025 level of significance. This is going to be a one-tailed test since it's a greater than instead of an equal to. So you're going to consult your table again. I'm going to zip over here, bring up my table, and so we said n was equal to 9. I got to erase that so we can see what's going on. N is equal to 9. We were doing a one-tailed test at a 0.25 level of significance, so our critical value is just going to be 1. One-tailed test at 0.25, so 1 is our critical value. Going back over here then, we know our critical value was 1. Whoops, let me get rid of this stuff. The value of our test statistic. So again, this one was less than 30, more, exactly, more. We have one negative, and 1, 2, 3, 4, 5, 6, 7, 8 positive. That was our n equals 9, how we got our numbers. Our value of our test statistic is 1. I always take the lower of my 2 when I count up my negatives and my positives. I'm going to compare those values. 1 is less than or equal to 1. Notice the equal sign in there. When we said it was less than or equal to, our decision there was to reject the null. So again, I got to think about my hypothesis. My alternative one was the greater than 30. My null was less than or equal to 30. This one is the not true one. So this one is the true statement. Because we decided we should reject the null since 1 is less than or equal to 1. We're going to reject the null. So can we conclude that the medium attention span for children playing with this toy is greater than 30? Yep, it is greater than 30 is the true statement. So yes is going to be the answer to the question.